Viitorul e al tău, noi punem temelia. UTCP, construim pentru România. UTCP, Universitatea de Construcții București.
Okay. Thank you, everyone. I'm the director for overseas projects in the Ministry of Land, Infrastructure, Transport and Tourism in Japan, MRIT. As my supervisor, Mr. Onodera, mentioned in his opening remarks, I would like to thank you for inviting us to this very meaningful and for meaningful workshop and for providing us such a great opportunity as well. Prior to today's lecture, I was told beforehand that many members in your country, Romania, says interested in not only seismic risk, earthquake risk, but also the status of the infrastructure maintenance, especially for bridges. So, therefore, I would like to give a lecture from the standpoint of the MRIT so that I can answer such questions. Thank you. And next slide. Okay. So, perfect. In today's presentation, I would like to divide my talk into three main parts. First, I will talk about background and issue on infrastructure maintenance. Okay. First, I would like to introduce a major turning point about maintenance policy in my country. First of all, most of Japan's road infrastructure, such as bridges and tunnels, was constructed during the period of high economic growth in my country, mainly around 1960s. Therefore, the number of infrastructures that were built more than 50 years after construction recently increased at an accelerating pace. And as a result, maintenance of road infrastructure has long been positioned as an important policy by MRIT. One of the major turning points in Japan's maintenance policy was the accident at the Sasago Tunnel, a highway tunnel in Japan, as shown in the photo below left, just after the accident. In 2012, as shown in the upper left figure, there were concrete stadium panel suspended from the concrete above the tunnel. They suddenly fell, and as a result, killing totally 9 people. The cause of the falling stadium panel was due to lack of maintenance of the bolts, upper bolts. And in Japan, the law of the road has already existed in this time. But however, the law only mentions the minimum responsibility about road maintenance for each road administrator. After this accident, MRIT had recognized this accident as a serious accident and revised the law of road in 2013, the following year of the accident. And as the first year of maintenance, we have decided to start inspect bridges, tunnel, and other road infrastructure in accordance with the new road regulations. According to the revised new road law in 2014, this new road law regulation was enacted. This new regulation clarifies that all road infrastructure must be inspected once every 5 years. And periodic inspection are the important duty for all road administrators, which led to start of simultaneous inspection in my country. Currently, we are now proceeding the second round inspection and preventive maintenance in the road maintenance. Okay, next I'd like to explain the current status of Japan's aging infrastructure. This graph shows the percentage of road bridges, tunnels, rivers, sewers, ponds, etc. that are more than 50 years old after construction. Gray shows the percent in 2012, and beige in 2013, and red in 2014. As I mentioned earlier, the situation in Japan is such that much of the infrastructure was built in the 1960s, and we are about to see an accelerating increase in the number of infrastructure that are more than 50 years old. Among these, focusing on road infrastructure, such as bridges or tunnels, the percentage of those that are more than 50 years old after construction will be about 75% in 2014, and for tunnel about 53%, where this percentage is higher than other infrastructure such as for river or soils. Next slide. Okay, I want to pass. So next part, I want to explain establishment of maintenance cycle. First, we would like to explain the trends in Japan's road-related budget. The graph above shows the budget for the governmental direct budget, which has been maintained at approximately 1.4 to 1.2 trillion yen since 2010 in the initial budget. This scale is roughly equivalent to $10 billion in US. And in this amount, the red line represents maintenance and repair expenses, which in 2010 amounted to approximately 200 billion yen, or only 60% of the total budget. However, after the accident of the Seismic tunnel in 2012, the percentage of maintenance and repair expense has been increasing year by year, and recently it has reached approximately 29% of the total, for example, or 440 billion yen for the government's direct budget. Thus, LRIT is striving to secure the budget for maintenance and repair expense under the direct control of the government. Next slide. This slide shows additional financial program by government, which requires infrastructure maintenance. Actually, the previous graph shows only the initial budget under the direct control of the national government in Japan. But, however, in my country, infrastructure maintenance is being addressed through additional financial measure based on this program, which is a separate framework from the initial budget. The name of this program is defined as a 5-year accelerated measure for disaster prevention, mitigation, and national land resilience, as the title suggests. The purpose of this program is to invest 15 trillion yen, nearly $100 billion in US, over the 5 years from 2021. In these projects that contribute to disaster prevention, disaster mitigation, and national land resiliency. This is just government as a whole. And of this amount, the portion that contributes to the LRIT is estimated to be approximately 9.1 trillion yen. In addition, measures to address aging infrastructure in order to shift to preventive infrastructure maintenance are also included in this amount, which is estimated to amount to approximately 1.5 trillion yen over a 5-year period. So if we take divisive approach, it indicates the idea of taking additional measure on the scale of about 3 billion yen per year. The background to the establishment of this program is that in addition to the increased importance of maintenance, there have been enormous disasters in Japan which led to the establishment of a separate program that combines maintenance and disaster prevention as well in this way. Okay. So next slide. This slide shows describes the essence of importance of road maintenance cycle. As I mentioned first of the presentation, legal inspection of road infrastructure began in 2014 in my country. But the first important element of the maintenance cycle is to develop inspection strategic plan, and then inspect the road infrastructure based on this plan. Second, it is also important to implement diagnosis based on the inspection results. Then, if there is any damages, it is important to repair it promptly according to the level of urgency and the importance of the infrastructure. Finally, we must not forget to recall the result. I want to say, of course, it is important for the human body to undergo periodic health checkups, and same as it is very important to ensure that the infrastructure is maintained based on this maintenance cycle, I would say. And as for this maintenance cycle, it is generally recognized that its components are totally four components, just like this: inspection, diagnosis, repair action, and recordings, as shown in this row. Okay. This next slide, and as I explained repeatedly, that diagnosis is positioned as a part of the maintenance cycle in my country, Japan. This graph shows the result of diagnosis of bridges, tunnel, or road accessories. In other words, this is just a checkup, health checkup in each infrastructure. First of all, to in the road sector or bridges and the tunnel, inspect once every 5 years by a product visual inspection. Based on the result of this inspection, each road administrator is required to determine the soundness of bridges by a total of four categories by the law regulations. Soundness classification from 1 to 4. Through discussion with experts who are familiar with bridge damage and other factors. These diagnosis categories are also based on the law, law of the road, and technical standards based on this new law. These diagnostic regulations are uniformly applied throughout the country, and these diagnoses must be made not only for each damages, but also for the structure as a whole. These diagnosis categories are 1 for sound, good, 2 for preventive stage, 3 for early major stage, and last 4 for urgent major stage. For example, the photo on the upper right, which shows exposed reinforcing steel bars in the floor plate, is classified as classification 3, while the photo on the lower right, which shows soiling of the bridges, is classification 4. Next, I would like to explain our attitude and approach to maintenance in my country, Japan. The most important concept is to implement preventive maintenance rather than breakdown maintenance, I want to say. In other words, it is important to shift from breakdown maintenance, in which just go in this graph shows that in which repair and other measures are taken only after failure has occurred in the function or performance, to preventive maintenance, in which repair and other measures taken before failure occurred. Just read in this slide, I would say. It shows that graph of preventive maintenance, red cycle, please see the cycle, will have a longer service life and lower the cost of each and every maintenance than breakdown maintenance, just blue one. Of course, as a result, the total cost can be reduced as shown in the image on the right. Okay. Next, I want to show the concept of the preventive maintenance. This is shown here with the specific images. The point is to maintain the functionality of each facility by repairing the damage at a minor stage before it became serious and required a large scale response. The lower left gray shows just example which was recognized as breakdown maintenance, where damage was left as it was and major repair was made only after the damage became serious. Specifically, the bridge's superstructure was renewed by replacing the pressure slab. On the other hand, as shown in the upper left blue one, in the upper left photo, small scale measure can be taken by repairing the damage at the minor stage. Also, as shown in the photo on the right, it is important to minimize the total cost, including the use of highly durable material and labor saving during operation when renewing facilities. Okay. We will then provide additional explanation from the specific monetary benefits and cost savings. According to the survey results of the 2018 estimate, if maintenance is performed based on the breakdown maintenance approach, it will cost approximately $8 to $2.8 billion for maintenance and renewal cost after 30 years. This is so big deal. And on the other hand, estimated based on the preventive maintenance approach resulted in an estimated cost of approximately $43.8 billion after 30 years. It means the total reduction will be about 50%. The total cost over 30 years can also be reduced by about 30% as well. Thus, it is important to realize sustainable and efficient infrastructure maintenance by shifting from breakdown maintenance to preventive maintenance and improving efficiency through the active use of new technology or data. Okay. So what we see? I want to explain number 3, integration of new tech and data in this session. MLIT in my country has a technology system called the New Technology Utilization System, NETIS, which is designed to actively utilize useful new technology developed by the private sector in public work projects. The graph on the left shows the result of a trial calculation comparing the cost and the process for inspection using conventional and new technologies. And as a result, it is estimated that the cost and process for inspection can be reduced by 50% and 32% respectively on average when comparing the conventional and new technologies. So, in the past, as shown in the photo above, inspection were concluded by using inspection vehicle while traffic was restricted in my country. But as shown in the photo below, the use of the drone and other technologies to check for damage is being actively promoted in my country. In addition, since 2 years ago, MLIT has decided to utilize these inspection support technologies in principle for the periodic inspection work of bridge and tunnel. In this way, our government is taking the lead in utilizing new technology, as we have some responsible for the development and the diffusion of inspection technology. To pass it. Okay. Okay. Now we minority also working on the creation of the platform for road data. In Japan, there are various types of data related to roads, such as facility specifications, inspection results, and traffic volume. Based on this, the MLIT is promoting the creation of a database of various data collected and accumulated by road administrators. And we are now building a new data platform called Crossroad in this slide. We have started to compile a database of road facility specification and inspection results for the area circle, red circle, by the red dot line in the figure. And in July 2022, we were able to compile a vast amount of data from road facility inspection nationwide and make this database available to the public now. This is just an example. This slide shown as a damage map. Database of inspection results regarding road facility nationwide that is currently available to the public. Just like this. In this map, when we click on facility on the map, the facility specification, inspection data, and contamination status are displayed in the map, as well as information on traffic volume. In this way, MLIT provides easy to understand information on the current status of infrastructure and issue through visualization of information such as inspection result of road facilities. Okay. I want to. This is today's last slide, and although it is still a process of trial and error in Japan in terms of road infrastructure maintenance, especially for bridges, but I hope that today's lecture will be some of help of Romania members as well. Thank you very much for your kind attention. Thank you.
Viitorul e al tău, noi punem temelia.